Internal combustion engines provide outstanding drivability and durability, with more than 250 million highway transportation vehicles in the United States relying on them. Along with gasoline or diesel, they can also utilize renewable or alternative fuels, for example, natural gas, propane, biodiesel, or ethanol. They could also be combined with hybrid electric powertrains to increase fuel economy or plug-in hybrid electric systems to extend the range of hybrid electric vehicles. How does an internal combustion engine work? Combustion, also known as burning, is the basic chemical process of releasing energy from a fuel and air mixture. In an internal combustion engine, ICE, the ignition and combustion of the fuel occurs within the engine itself. The engine then partially converts the energy from the combustion to work. The engine consists of a fixed cylinder and a moving piston. The expanding combustion gases push the piston, which in turn rotates the crankshaft. Ultimately, through a system of gears in the powertrain, this motion drives the vehicle's wheels. There are two kinds of internal combustion engines currently in production: the spark ignition gasoline engine and the compression ignition diesel engine. Most of these are 4-stroke cycle engines, meaning 4 piston strokes are needed to complete a cycle. The cycle includes 4 distinct processes: intake, compression, combustion and power stroke, and exhaust. Spark ignition gasoline and compression ignition diesel engines differ in how they supply and ignite the fuel. In a spark ignition engine, the fuel is mixed with air and then inducted into the cylinder during the intake process. After the piston compresses the fuel-air mixture, the spark ignites it, causing combustion. The expansion of the combustion gases pushes the piston during the power stroke. In a diesel engine, only air is inducted into the engine and then compressed. Diesel engines then spray the fuel into the hot compressed air at a suitable, measured rate, causing it to ignite. Improving combustion engines. Over the last 30 years, research and development has helped manufacturers reduce ICE emissions of criteria pollutants, such as nitrogen oxides, NOx, and particulate matter, PM, by more than 99% to comply with EPA emissions standards. Research has also led to improvements in ICE performance, horsepower and 0 to 60 miles per hour acceleration time, and efficiency, helping manufacturers maintain or increase fuel economy. Learn more about our advanced combustion engine research and development efforts focused on making internal combustion engines more energy efficient with minimal emissions. An internal combustion engine, ICE or IC engine, is a heat engine in which the combustion of a fuel occurs with an oxidizer, usually air, in a combustion chamber that is an integral part of the working fluid flow circuit. In an internal combustion engine, the expansion of the high temperature and high pressure gases produced by combustion applies direct force to some component of the engine. The force is applied typically to pistons, turbine blades, a rotor, or a nozzle. This force moves the component over a distance, transforming chemical energy into useful kinetic energy, and is used to propel, move or power whatever the engine is attached to. This replaced the external combustion engine for applications where weight or size of the engine is important. The first commercially successful internal combustion engine was created by Etienne Lenoir around 1864, and the first modern internal combustion engine was created in 1876 by Nicholas Otto, see Otto engine. The term internal combustion engine usually refers to an engine in which combustion is intermittent, such as the more familiar 4-stroke and 2-stroke piston engines, along with variants, such as the 6-stroke piston engine and the Wankel rotary engine. A second class of internal combustion engines use continuous combustion, gas turbines, jet engines and most rocket engines, each of which are internal combustion engines on the same principle as previously described. Firearms are also a form of internal combustion engine, though of a type so specialized that they are commonly treated as a separate category. In contrast, in external combustion engines, such as steam or Stirling engines, energy is delivered to a working fluid not consisting of, mixed with, or contaminated by combustion products. Working fluids for external combustion engines include air, hot water, pressurized water or even liquid sodium, heated in a boiler. ICEs are usually powered by energy-dense fuels such as gasoline or diesel fuel, liquids derived from fossil fuels. While there are many stationary applications, most ICEs are used in mobile applications and are the dominant power supply for vehicles such as cars, aircraft and boats. ICEs are typically powered by fossil fuels like natural gas or petroleum products such as gasoline, diesel fuel or fuel oil. Renewable fuels like biodiesel are used in compression ignition, engines and bioethanol or ethyl tert-butyl ether, produced from bioethanol and spark ignition, engines. Renewable fuels are commonly blended with fossil fuels. Hydrogen, which is rarely used, can be obtained from either fossil fuels or renewable energy. Reciprocating piston engines are by far the most common power source for land and water vehicles, including automobiles, motorcycles, ships and to a lesser extent, locomotives. Some are electrical but most use diesel engines. Rotary engines of the Wankel design are used in some automobiles, aircraft and motorcycles. These are collectively known as internal combustion engine vehicles, ICEV. Where high power-to-weight ratios are required, internal combustion engines appear in the form of combustion turbines or Wankel engines. Powered aircraft typically uses an ICE which may be a reciprocating engine. Airplanes can instead use jet engines and helicopters can instead employ turboshafts, both of which are types of turbines. In addition to providing propulsion, airliners may employ a separate ICE as an auxiliary power unit. Wankel engines are fitted to many unmanned aerial vehicles. ICEs drive large electric generators that power electrical grids. They are found in the form of combustion turbines with a typical electrical output in the range of some 100 megawatts. Combined cycle power plants use the high temperature exhaust to boil and superheat water steam to run a steam turbine. Thus, the efficiency is higher because more energy is extracted from the fuel than what could be extracted by the combustion engine alone. Combined cycle power plants achieve efficiencies in the range of 50% to 60%. In a smaller scale, stationary engines like gas engine or diesel generators are used for backup or for providing electrical power to areas not connected to an electric grid. Small engines, usually two-stroke gasoline/petrol engines, are a common power source for lawnmowers, string trimmers, chainsaws, leaf blowers, pressure washers, snowmobiles, jet skis, outboard motors, mopeds, and motorcycles.